Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 paper 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Total time for this exam is 1 hour and 15 minutes. There are 40 questions on this paper. You need to answer all of them. And total mark for this paper is 40. On the second page of exam paper, some important data mean values of some important constants are given to you, and also some important and basic formulae are also given. So in the exam, if you need value of any constants, you can come to the second page and you will be able to find values of standard constants. Question 1 says, what is a reasonable estimate of the cross-sectional area of the wire in a paper clip? So first of all, you can look at this paper clip and you can try to estimate what is the diameter of this paper clip. So this one is the diameter, or simply you can say is the thickness of the paper clip. Now, if you have sense of scale, if you have looked at meter rule carefully, you can simply say that this diameter can be about 1 to 2 millimeters. So this question is simply about sense of scale. As a physics student, you should have sense of scale. You need to understand how big is millimeter, how big is centimeter, and how big is a meter. So this sense is very important. You don't need to memorize a lot of things. You need to develop your understanding. So for this question, we need to calculate cross-sectional area. So simply we can say this will be equal to pi by 4 d square. So we can now just plug in value of the diameter. So we can take 1 millimeter. Even you can take 2. There will be no big difference. So we can say the power of this one is minus 3 because the unit we're using is meter, because here we have meter square, and the power of this one is 2. So if we solve this one, we will get pi by 4 times 10 to minus 6 meter square. So this is meter square. If we solve, finally we will get 7.8 times 10 to minus 7 meter square. So this is the final answer. Now if you look at given options, the order of magnitude of this one is 10 to minus 7, and we also got 10 to minus 7. So the answer for this question is C. So the answer for this one is C. You can see this is 10 to minus 5, a very big difference. This is 10 to minus 3, a very big difference. That's the reason simply you need to estimate. If you have sense of scale, you will get your answer right. And this has 10 to minus 9 means the order of magnitude of this one is 10 to minus 9. So just estimate. So try to develop sense of scale. If you have sense of scale, you can answer this type of problems. Question 2 says, which quantity is not an SI base quantity? So we have 7 SI base quantities. So if you look at the given options, mass is SI base quantity, temperature is SI base quantity, time is SI base quantity, but charge is not SI base quantity. Current is SI base quantity. So simply you need to understand current is SI base quantity, but charge is not. So the answer for this question is A. Question 3 says, a student determines the acceleration of free fall by using a small metal ball, as shown in the figure. When switch S is open, the ball is released from an electromagnet and an electronic timer is started. The ball then falls vertically downwards. The timer stops when the ball hits a trapdoor. The student measures the distance PQ between the electromagnet and the trapdoor. This distance and the reading on the timer are then used to calculate the acceleration of free fall. Which statement about errors in this experiment is correct? So first of all, we need to understand what distance we have to measure. So we can imagine simply, first of all, the ball was here. It was attached with electromagnet, and finally ball is here. So we have measured the time between these two intervals. So we have measured time between these two positions of the ball. So we can also draw one line here. So we have to measure this distance from the center of the ball, from here to the center of the ball at this position, mean we have to find out this distance. This distance we have to find out. So we can also label this one, this distance we have to find out. Let's say this distance is equal to d. So we can write down d in this case will be equal to pq minus, so you can see the radius of the ball here is extra and radius of the ball here, this is also extra, so this is extra. So we have to subtract this one, so we have to subtract diameter of the ball. So this is the distance we need to calculate acceleration, because this is the distance traveled by the ball in given period of time, mean the time recorded by the timer. So we have to use this distance. Now how we can use this one, just for better understanding, so for this experiment we can use the formula S is equal to ut plus 1/2 at square. In this case ball started from rest, so it means u will be 0, so it means this term will be equal to 0. So we can say S is equal to 1/2 at square. In this case S is equal to d, means that this distance, and this is equal to 1/2 at square. So from here a will be equal to 2d over t square. A beautiful question, nice question, little bit tricky one. Now if you look at given options, first one is telling us the random error can be reduced by adding the diameter of the ball to the distance pq. Not adding, we have to subtract, and this will change by a certain amount, means it will change by fixed amount, so there will be a pattern. So let's explain you a little bit more about that. What is systematic error and what is random error? Systematic error means that we will see a pattern. We will see a pattern, or we can simply say readings will change by certain amount, or we can say by fixed amount. For simplicity we can say for fixed amount. And random error means that no pattern. Sometimes we will see readings are greater than actual value, sometimes we will see they are smaller, so there will be no pattern. For the random error we can say, if there is a random error, there will be no pattern. There will be no pattern. So the readings will be greater, means sometimes they will be positive, or reading will be negative, positive and negative. So for this one we can say positive and negative. So we will see positive values, we will see negative values, positive and negative. But in this case we will see only positive, or we will see only negative, means answer will change by a fixed amount. So this has to be a systematic error, so this cannot be random error. So this is also incorrect. Random error can be reduced by subtracting the diameter. Subtracting diameter is accurate, this is correct, but random error, no, this has to be systematic error. So this is also incorrect. Systematic error can be reduced by adding the diameter. No, in this case we have to subtract the diameter. As we mentioned here, we have to subtract. So this is incorrect. Systematic is correct. Systematic error can be reduced by subtracting, yes, the diameter of the ball from the distance pq. So the answer for this question has to be D. The main concept, the takeaway from this question is that distance should be measured from the center of the ball to the center of the ball, mean distance between center of mass of the ball. That distance we have to use for calculations of acceleration, because that is the distance traveled by the ball in time recorded by the timer. So the timer has recorded the time when the ball has traveled this distance. So this is the distance we need to use in the formula to calculate value of A. Very nice thing. So physics is about understanding, so your mind should be open. Question 4 says the diagram shows two coplanar forces P and Q drawn to scale. Force R is given by R is equal to Q minus P. Which diagram represents R? So first of all, simply we can rewrite this one. So we can say R is equal to Q plus minus P, means the negative vector of P. So how we can draw the negative vector of p? So simply we can take one arrow, we can draw here. So this is the negative vector of p. Now we can simply copy this vector. So this is our vector, we can copy this one. So we can simply draw this dotted line and we can copy this one and we can place here. So the resultant in this case, resultant is this one. So this vector is the resultant. This is resultant vector. So we can say this one is minus p and this one is the r. So the answer for this question has to be C. Question 5 says a parachutist falls from a stationary balloon at time t is equal to 0. The velocity time graph for the parachutist from time t is equal to 0 until the time when he is just above the ground is shown in the figure. Which graph best shows the variation with time of the acceleration of the parachutist? So it simply means that we have velocity time graph and we need to figure out which one is the corresponding acceleration against time graph. So simply we need to understand that gradient of VT graph, represents acceleration. So this is the main concept we need to understand. Now if you look at the gradient at this point, this gradient is positive, so it means initially acceleration has to be positive. So it means answer C is not possible and D is also not possible. So we can simply negate these two answers. Now the answer can be A or answer can be B. Now we need to compare the gradient. Gradient here, if you look at this part of the graph, this gradient is very steep. It means acceleration here has to be much greater than the acceleration here. So if we compare these two gradients, so this acceleration has to be greater and this gradient is negative. So we can say this gradient is negative. So the negative acceleration has to be much greater. So the answer for this question has to be B, because this acceleration is small, it almost equal to this one, and this one is much greater than the initial acceleration. So it means the answer for this question is B. That's all what you need to understand. And this is a typical question. Sometime in the exam, simply they can ask you in paper 2 to sketch acceleration time graph for the velocity time graph, means for this parachutist they can ask you about that, or simply for skydiver they can ask you to sketch acceleration against time graph. So it's very important to understand how to sketch acceleration against time graph for a skydiver or for a parachutist. So the answer for this question is B. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023 Paper 1 Variant 1. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 6 says, a projectile is fired from point P with velocity v at an angle theta to the horizontal. It lands at point Q, a horizontal distance capital R from P after time capital T. The acceleration of free fall is g, a resistance is negligible. Which equation is correct? So simply for this question we need to calculate what is value of R, means which equation we can use to calculate value of R. R is the range, or simply you can say this is the horizontal displacement. So we can say this is horizontal displacement. As there is no force along horizontal, it simply means that horizontal component of initial velocity, it will remain constant. Mean at any given time horizontal component of velocity will be equal to the horizontal component of initial velocity. So simply we can say we have to take Vx multiply by time taken, and Vx is equal to V cosine of theta times time. So we have times time. So we can say this is equal to v times t cosine of theta. So we have initial velocity and the horizontal component is v cosine of theta. So the answer for this question has to be A. Question 7 says a man stands in a lift that is accelerating vertically downwards as shown in the figure. Which statement describes the force exerted by the man on the floor? So first of all, we need to understand acceleration is downward. So this is direction of acceleration. So the net force also has to be in downward direction. Now, if we look at the forces acting on the person, there are two forces acting on the person. One is the gravity, that is equal to the weight of the person, and the second is the pushing force by the ground. So we can say this is normal reaction force. As this person is accelerating downwards, it simply means that W is greater than N, or simply you can say N is lower than W. For this question, we need to find out force exerted by the man on the floor. So we can say N, this is the force on person by the ground. So we can say by the ground. So this is the force on person by the ground. We can also use this arrow, means this is a vector. And the force here, we can say this is another N. We can say this is the force on ground by person. So this is force on ground by person, or you can say by the man. And these two forces, they have the same magnitude, but they are in opposite directions. So this is the main concept here. So if this point is clear to you, now we can figure out answer. Option A says it is equal to the weight of the man. No, it is lower than. So this is not possible. It is greater than the force exerted by the floor on the man. No, they are equal in magnitude. So this is also incorrect. It is less than the force exerted by the floor on the man. No, they are equal. So this is also not possible. It is less than the weight of the man. Yes. So it is less than weight of the man. Beautiful question, nice question, just conceptual. So if your basic concepts are not clear, maybe you will be struggling with this problem. So these 2 points you need to understand. First of all, acceleration is down. It means the net force is downwards. Then we can look at the forces acting on the person. So there are 2 forces acting on the person. One is the weight and one is the pushing force from the ground. And the force by and the pushing force by the person on the ground, that has to be equal in magnitude to normal reaction force, but opposite in direction, because these 2 forces, they are action and reaction forces. Action and reaction, they form Newton's third law pair. So that's the reason they have same magnitude, but they have opposite direction. So the answer for this question has to be D. Question 8 says a ball of mass 200 gram is thrown horizontally with a speed of 20 meters per second against a vertical wall. The ball is in contact with the wall for a time of 0.10 seconds before rebounding back along its original path with a speed of 10 meters per second. What is the average force exerted by the wall on the ball during the collision? So this is a typical type of question. You will see this question means based on the same concept every year in every paper almost. So the best way to answer this question is simply we can sketch. First of all, we can imagine this one is the vertical wall and the ball is coming. Mass of the ball is given. We can say the mass of this one is 200 grams. It means this is 0.2 kgs. The initial speed of this one we have, that is u, and u is equal to 20 meters per second. And the speed of this ball after rebound is also given to us. We have value of v, that is equal to 10 meters per second. We need to calculate the average force on the ball. And so we need to calculate value of F average. This is simply equal to the change in momentum over time taken, means over time in contact. So in this case we need to understand force exerted by the wall on the ball. So the force on the ball by the wall will be in this direction. So this is direction of the force. So force on the ball will be in this direction. So this is direction of force on the ball. So we will take in this case to the left positive. So this is very important point. So we will take to the left is positive. So it means this is negative and this one is positive. Now simply we can use m times v minus u divided by delta t. So we have value of mass, that is 0.20 kgs, and value of v, this is 10, minus, and u is negative, so this is minus 20, divided by time in contact, that is 0.10. Now if we simplify this one, we will get 0.20, and here we will get 30 divided by 0.10. Now if we solve this one, we will get our final answer, that will be equal to 60 newtons, and this answer is positive. So it means direction of force is to the left on the ball. So this is how you can figure out typical question, and in every paper you will see at least one question based on this equation. So it's very important to understand how to use this. So the answer for this one is B. Question 9 says, in an experiment, a metal ball is dropped into a viscous liquid. The terminal velocity of the ball in the liquid is measured. The experiment is repeated 4 times. For each repeat, a change is made to one of the following: the density of the metal of the ball, the height from which the ball is dropped, the density of the liquid, the depth of the liquid. Which two changes separately affect the terminal velocity of the ball in the liquid? This question is a little bit tricky one, so let's try to answer this one step by step. First of all, we can simply imagine we have a cylinder, so you can just imagine this one is the cylinder, and this cylinder is filled with viscous liquid. So we have viscous liquid inside this cylinder. We can also imagine a ball, so here we have a ball. This is the ball. For this question, we need to consider the effect on terminal velocity. And terminal velocity, first of all, we need to understand this is the constant velocity. So simply we can say this is constant velocity. Constant velocity means that the net force on the ball will be equal to 0 when it has reached terminal velocity. Now if you look at the forces acting on the ball when it has reached terminal velocity, I hope you will simply say the force acting downwards, this force will be the weight of the ball, and there will be up thrust on this one. Up thrust will be very small, we can say this is the up thrust, and also there will be a drag force, we can say that is Fd. So simply we can say in this case W has to be equal to up thrust plus drag force. In this case, up thrust will be constant quantity, so this quantity will stay constant, and as the density of the liquid is much lower than density of the ball, so it means that up thrust will be very small. For simplicity and for better understanding of this problem, we can simply say in this case when the ball has reached terminal velocity, weight will be equal to drag force, and drag force is equal to 6 pi eta r times v, and v is the terminal velocity. So we can also say weight of the ball, that will be equal to the density of the ball times the volume of the ball times g. Now if simply we look at this equation, if I keep, for example, the size of the ball, if we keep constant, and if we keep the viscosity of the liquid constant, it means that terminal velocity also has to be constant. So terminal velocity also will stay constant. If we're using the same liquid all the time, it means that terminal velocity will be the same. If we keep the density of the ball same, we keep the volume of the ball same, so it means that terminal velocity will remain constant. If we change the viscosity, for example, if we change the viscosity and we keep this same, so it means V will change. For example, if we increase the viscosity and all other factors we keep same, it means the terminal velocity will go down, and vice versa is also true. So it simply means that if we change, for example, this density of the ball, let's say we change the density of the ball, we increase the density of the ball, and we keep other factors same, means we keep all these factors same. So it means the terminal velocity has to increase. Terminal velocity has to increase. So these are some basic points you need to understand. I hope you start understanding how to answer this problem. Now if you look at the given options, for option 1 means here the density of the metal of the ball. If we change this density, it means the terminal velocity also will change. So it means this we have to consider. This will affect the terminal velocity. Height from which the ball is dropped, it does not affect. But this is a tricky one. Most of you will be struggling with this one. Why height is not affecting? The reason is that, let's say if I drop the ball from this point, when the ball will reach at this point, it will have different velocity. We can say, let's say it has velocity v1. If we drop the ball from this point, when the ball will reach this liquid, let's say its velocity is v2. Its velocity will be different, initial velocity will be different, but when the ball is here, it has reached terminal velocity. If we keep the density same, we keep the viscosity of the liquid same, we keep the size of the ball same, r same, so how about the terminal velocity? I hope you will say in both cases we drop the ball from this point or we drop the ball from this side, when it will finally reach terminal velocity, that will be the same all the time. So we can say at this point Vt1, this will be equal to Vt2. Terminal velocity will be the same. I hope this makes sense to you. Another way of understanding this one is, it will take a little bit long time, but you can simply understand if at this point, let's say V1 is greater than the terminal velocity, let's say V2 for example, V2, because height is greater than terminal velocity, what will happen when the ball will enter water? The viscous force will be much greater than the weight. So it means acceleration will be in upward direction, so the ball will slow down. It will finally come down to terminal velocity. So that's the reason. So it means height will not affect. So this one we can ignore. Density of the liquid, yes, density of the liquid is linked with the viscosity of the liquid. So these two quantities, they are linked with each other. So if density of the liquid will change, it means we change the concentration of particles. It means the viscosity also changes. So this one will affect. Depth of the liquid, it doesn't matter how deep is this liquid. When it has reached terminal velocity, it will just go with the same velocity down. I hope you will say we can also ignore this one. It will not affect the terminal velocity. I hope this makes sense to you. If still it is not clear, you can leave your questions in comments and I will try to answer. It's very important. Try to picture this one in your mind. So the answer for this question has to be B. So B is the right answer. A beautiful question, conceptual question. Try to visualize this one. And if one time this is not clear to you, watch video again, it will be clear to you. And if this explanation was helpful, please like and subscribe, and also leave some comments in comments section. And if you need more help and you're looking for extra resources, you can also join Patreon, and the link for Patreon you can find in the description of this video. Question 10 says two objects move towards each other along the same straight line. After colliding, the two objects stick together and objects are stationary. Which statement must be correct? So it is given to us these two objects, they collide, and after collision they stick together, and these objects, they are stationary. So it simply means that the final momentum is equal to 0. So by conservation of momentum for an isolated system, so we are treating this system as an isolated system. So the initial momentum has to be equal to the final momentum. Now, if you look at given options, for option A, it is given to us the total kinetic energy of the objects does not change during the collision. Kinetic energy has been changed because they are at rest. So it means kinetic energy, final kinetic energy is equal to 0. So it means that total kinetic energy changes. So this option is incorrect. The total momentum of the two objects before the collision is 0. Yes, this is true because we are treating this one as an isolated system. So the initial momentum has to be equal to final momentum. So this can be the answer. The two objects have equal mass. This is not important. Even their mass is different. If their initial momentum is 0, the final momentum also will be equal to 0. So this is not correct. The two objects have the same speed before the collision. If the mass is different, the speed will be different. But these two objects, they have the same momentum but in opposite direction. So that's the reason momentum before collision is equal to 0. So the best answer for this question is B. The point you need to understand is for an isolated system, total momentum is 0, means the change in momentum is equal to 0. It simply means that momentum before collision is equal to momentum after collision. Same magnitude and also same direction. Or simply you can say change in momentum has to be equal to 0. So the answer for this question is B. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October November 2023, paper 1, variant 1. As always we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 11 says a minimum torque of 20 newtons meter must be applied to the lid of a jar for jar to open. The radius of the lid is 4.0 centimeters. What is the minimum force F that must act on each side of the lid in order to open the lid? This question is simply about torque of a couple. So simply we can say torque of a couple. Torque of a couple. So this question is simply about torque of a couple. So we can write on this couple in a better way. Torque of a couple. And torque of a couple is equal to the product of one force time perpendicular distance between forces. So we can say perpendicular distance between forces. So if you look at this given figure, so we can draw this horizontal line here. So we have two forces in this case, one force here, another force is here, and this is at an angle of 90 degree and this is also at an angle of 90 degrees. So this is the perpendicular distance. We can say this one is perpendicular distance, and this distance is equal to 2 times of radius. So we can say this is equal to 8.0 centimeters. Now everything is given to us. We have the value of the torque, so we can write down this is 20 newtons meter. We have to find value of F, but we have value of perpendicular distance, that is 8.0 centimeters. So it means this is 8 times 10 to minus 2 meters. So if we simply solve this one, so we have 20 newtons meter divided by 8.0 times 10 to 2 meters, and our final answer in this case will be equal to 250 newtons. So this is how we can figure out. Pretty straightforward question. So the main concept is this one: how to calculate torque of a couple. So the answer for this question has to be C. Question 12 says a uniform bar of length capital L and weight W rest horizontally on two supports X and Y. Support X exerts a vertical force Rx at a distance of L by 6 from one end of the bar. Support Y exerts a vertical force Ry at the other end of the bar. The bar is in equilibrium. What is the ratio between Rx and Ry? For this question, it is given to us, it is in equilibrium. Even if it is not given to you, it is in equilibrium. In most of the cases, you can assume that it is in equilibrium. For this question, they have specified this is in equilibrium. Equilibrium simply means that sum of the forces in any direction is equal to 0 and resultant moment about any point is also equal to 0. We can say resultant moment about any point is equal to 0. We need to find the ratio between these two forces, so we can take our pivot point at the midpoint of the beam, at the midpoint, so we no need to worry about weight. You look at the given options, we don't see weight in the answer, so it means we should take our pivot point at midpoint of the beam. Now simply we need to find out this distance. So let's say this distance is dx and this distance will be equal to L by 2 because the length of the beam is given, that is L. So how we can find out dx? Dx simply we can find out this will be equal to L by 2 minus L by 6. Now if we take LCM, we will get 6 and here we will get 3L minus L, so this will be equal to 2L by 6, or simply we can say this is L by 3. So this is value of dx. Now simply we have to take moment about this point. Moment due to this force, this moment will be clockwise. Moment due to this force, this will be anti-clockwise. So we can say Rx times L by 3, this has to be equal to L by 2 times Ry. We need to find out the ratio between Rx divided by Ry. So we can simply write down, we have L by 2, this will be multiplied by 3 by L. Now we can simply cancel L with L, so we left with 3 by 2. So this is our final answer. Simply we need to find the ratio between these two forces. So the answer for this question has to be A. Pretty straightforward question. Just read question carefully. You will be able to find the answer. Question 13 says a type of firework is made by connecting two rockets facing in opposite directions to a rod as shown in the figure. The rod is attached to a frictionless pivot so that the firework can rotate in a vertical plane. The firework has weight W. The pivot exerts a force capital R on the rod that is equal and opposite to W. Each rocket exerts a force of magnitude F on the rod at a perpendicular distance D from the pivot. The forces exerted by the rockets are always in opposite directions. Air resistance is negligible. Which statement is correct? So first of all, if you look at the forces, mean the sum of the forces acting on this firework, you can see these two forces are equal and opposite, and this force is equal and opposite to this one. So it simply means that resultant force is equal to 0. Now if you look at resultant moment, if we take our pivot point here, so moment due to these two forces will be equal to 0, and moment due to this force, this moment will be clockwise, and moment due to this force, this also will be clockwise. It means net moment is clockwise, is not equal to 0. It means that this system is not in equilibrium. So we can simply say not in equilibrium. So this is not in equilibrium. Now if you look at given options, it is given to us the firework is in equilibrium. This is incorrect. Is in equilibrium. This is also incorrect. Is not in equilibrium because the resultant force acting on it is not 0. this part is correct, but this one is incorrect. The firework is not in equilibrium because the resultant torque acting on it is not zero. So the answer for this question has to be D. So this is how you can answer this one. The main concept is this one. This is the main concept. If it was in equilibrium, resultant moment has to be equal to 0. As in this case, resultant moment is not equal to 0. It means this is not in equilibrium. So this will be rotating. So it has clockwise moment. Question 14 says, an object of weight W is suspended from a Newton meter. When the object is completely immersed in water, the Newton meter reads P. When the object is completely immersed in oil, the Newton meter reads Q. What is the ratio between density of oil and density of water? So in order to answer this question, first of all, we have to look at the forces acting on this object. So at this point, the weight of the object, this is acting vertically down. So we can say W is the weight of the object. And there is up thrust on this object that is acting vertically up. So we can say this is U. And also there is spring force that is equal to P. So in this case, simply we can write down up thrust. This will be equal to W minus P. So up thrust on the object when it is in water. So we can say this is UW. Now if you look at forces acting on the object when it is inside oil, we can write down here the weight of this object will be acting vertically down. There is up thrust on this one, that will be up, and the spring force is also acting vertically upward, that is equal to Q. For object, we can write down up thrust when it is in the oil will be equal to W minus Q. So this is, first of all, we can write down. Now we need to find out the density. As this is the same object, it means that volume is the same. And we need to understand up thrust is equal to rho times V times G. So this is equal to W minus P, and this is the density of water. Volume in this case is the same because the same object in two different fluids. So we can say this is our one equation. Simply we can say this is one equation. We can also write down up thrust in terms of density, volume, and G. So we have density of oil, so we can say this is density of oil times we have V times we have G. This is equal to W minus Q. We can say this is second equation. For this question, we have to find the ratio between density of oil and density of water. So simply we can divide 2 by 1. So here we have, this is 2, so we have density of oil times V times G. This is equal to W minus Q. We need to divide by 1, that is density of water times V times G, and this is divided by W minus P. W minus P. So simply here we can cancel this V with this V, this G with this G. So we left with density of oil divided by density of water. This is equal to W minus P. This is W minus Q. We have Q. So this is W minus Q divided by W minus P. So this is our final answer. So the answer for this question has to be W minus Q. So W minus Q. So this is W minus Q divided by W minus P. So the answer for this question is D. And this question is a repeated question. You can also see in other past papers. So this is repeated question. I hope this makes sense to you. Question 15 says a crate of mass 50 kg is pushed a distance of 6.0 meters along a horizontal surface against a constant resistive force of 70 newtons. The crate moves at a constant speed. It is then lifted at a constant speed through a vertical distance of 1.2 meters onto the back of a lorry. what is the total work done in this process? Means what is the total work done by the person in this process. So this is better way to say this one. Total work done by the force applied by the person. So how we can answer this question? The best way to answer this question is simply we can sketch. So this is the horizontal surface, then we lifted this block, and you can imagine this is the back of the lorry. So first of all, block was moving at constant speed at horizontal surface. So resistive force in this case is given to us Fr, that is equal to 70 newtons. So the applied force on this object has to be equal to 70 newtons as well. And in this case, as speed is constant, so the work done by applied force is equal to the work done by friction. So the net work done on the block will be equal to 0. So we can say W1. W1 is the work done. That will be equal to F times T. So simply that will be equal to 70 newtons times the distance 6 meters. And then we lifted this block, lifted. Delta H is given to us, that is equal to 1.2 meters. We lifted this block to the back of the lorry. So lifted to this certain height. So this is our block here now. When we lifted this block, work done will be equal to the change in GPE because speed is constant. So we can say this is W2. So the total work done in this case, we can say W total, this will be equal to W1 plus W2. And so we have 70 times 6 plus change in GPE, that will be equal to mg delta H. So we can also write on mg delta H. Weight of mass of the block is given, that is 50 kg. So we can say this is 50 times 9.81 times height, that is 1.2. So this is the total work done by the person. Now if we solve this one, our final answer will be equal to 1000 joules. So the answer for this question has to be D. Question 16 says the input power to a television is P in. The useful sound and light power emitted by the television is P out. What is the efficiency of the television? So first thing we need to understand, efficiency is simply equal to useful P out, useful E out, energy out, divided by total input power. So for this question we have useful P out, that is simply equal to P out, and P input means total input power, that is equal to P in. So the answer for this question has to be a quite straightforward question. Question 17 says a builder holding a brick of mass 300 grams drops the brick on his foot. What is a reasonable estimate of the change in gravitational potential energy of the brick? For this question simply we need to understand average height of a person. So we can say average height of a person. Average height of a person can be about 1.70 meters. Now this person is holding a brick and drop this in. So simply you can imagine as I'm holding this brick. So this is the brick I drop from here. So what is the height? Average height. So average height means the change in height average can be about 1 meter, roughly 1 meter. So we can calculate the change in GPE now. That will be equal to mg delta H. Mass of the brick is given, that is 300 grams. So we can say 3000 grams means times 10 to minus 3. You have to convert this one into kgs and multiply by 9.81, and the change in height approximately we have said is about 1 meter. So the final answer will be about 30 joules. This is a reasonable estimate. If you have estimated average height is about 1.7 meters, or even if you have estimated between 1 meter to 2 meters, still your answer will be right. So it's a reasonable estimate. It cannot be 300 joules. It's a very high number. This is also very high number. This is also very high number. So the answer for this question has to be A. Question 18 says an elastic cord of unstretched total length 16.0 centimeters and cross-sectional area 2.0 times 10 to minus 6 meter square is held horizontally by two smooth pins a distance 8.0 centimeters apart. The cord obey Hooke's law. A load of mass 0.40 kg is suspended on the cord. The angle between the two sides of the cord supporting the load is 60 degrees. What is the Young's modulus of the cord material? A typical question. So for this question, we need to calculate Young's modulus. And so simply we can write on here Young's modulus. This is equal to stress over strain. So simply we can say stress over strain. And stress is F over A divided by delta L by L naught. If we rearrange this one, we will get F times L naught divided by delta L times A. So this is delta L times A. For this question, we have value of L naught. So this is L naught. Original length of the string is given to us. A is given to us. So this is the cross-sectional area we have here. Now first of all, this is 16 centimeters long, but now if you look at this one, this is 24 centimeters long, so we can also find out value of delta L. So delta L will be equal to 24.0 centimeters minus 16.0 centimeters. So we have 16.0 centimeters. So we can say delta L is equal to 8.0 centimeters. So we have L naught, we have delta L, we have A. Simply we need to find out what is value of F. But F is very tricky one. Most of the time student, they simply remember this one. This is the force. But this is the force, this is the force acting on the string, this is the tension in the string. So what is F here? Most of the time student, they get confused with this. It not means that only the force acting on this one is the weight, so F is equal to weight. No, this is tension in the string. Very important one. What is this F? Tension in the string. So very important one. So what is F? F is tension in the string. So now simply we need to find out tension in the string. How we can calculate tension? So first of all, we need to understand tension here. This is acting up, so this is value of T. So tension here is also up. So we have to find out value of this T. And this T has two components, so we can draw here. We can draw one component is here. So this is the horizontal component of tension, and this side also has horizontal component. We can draw, this is the horizontal component, but this also has a vertical component. Vertical components we can draw here. So it has a vertical component, and we can draw here, it has a vertical component. So we can add arrows here. So tension is this way, this tension is this way, this component is up, and this component is also up. This is up. We can say this is Ty, we can say this is also Ty. Now we need to understand, if this angle is 60 degrees, this angle is 60 degrees, this angle also will be 60 degrees, this angle also will be 60 degrees. So we can say this angle is 60 degrees, this angle is also 60, so this angle also will be equal to 60 degrees. So from here we can say mg, this will be equal to 2 times of Ty. 2 times of Ty means Ty, these are two forces acting up, mg is down, so we can say this is equal to 2 times Ty. But Ty is equal to, so if this is T, so this will be Ty will be equal to T sine of this angle, that is 60 degrees. So we can say 2 times T sine of 60 degrees. We need to find out value of T, so we can say T will be equal to mg divided by 2 sine of 60 degrees. Now simply we need to plug in values. We have value of mass that is equal to 0.40, then we have value of g that is equal to 9.81. we need to divide by 2 sine of 60 degrees. If we solve this one, our answer will be about 2.2655 Newton. So this is value of T. Very tricky question, but very conceptual. Which force you have to take when you need to calculate Young's modulus? That is tension in the string. Now simply we can plug in values here. We have 2.2655 multiply by L naught, that is 16.0 centimeters, multiply by 2, and delta L we have, that is 8.0, so this is delta L. 8.0 centimeters means 10 to minus 2, and value of A we have, that is 2.0 times 10 to minus 6. Now if we solve this one, we will get our final answer. And in this case, value of Young's modulus will be equal to 2.3 times 10 to 6 Pascal. So the answer for this question has to be C. So this is how you can calculate. Very nice question. If one time it is not clear to you, watch this video again and try to clear your concept. So F is the tension in the string, and this question is a repeated question. If you check May June 2020 paper 1 variant 2 question number 18, the same question is there. So this question is repeated question. Beautiful question, conceptual. Try to understand this. Question 19 says, which force extension graph shows plastic deformation of a sample of material? So simply we need to understand what is plastic deformation to answer this question. Now let me ask you one question, very nice question. Place your finger on your cheeks, you will see the shape of your cheek will change. Now if you remove the finger, your cheek will come back to original shape. Now is it plastic deformation or not? I hope you will say this is not plastic deformation, because your cheek deformed temporarily and now it is back in original shape. So this is not plastic deformation. This kind of deformation we call is elastic deformation. So we call this is elastic deformation, mean it deformed temporarily. So we can say deform temporary. So deform temporary. So it returns to, so we can say returns to original size and shape. Original size and shape when we remove the force. Now we need to understand what is plastic deformation. Plastic. So let me explain you what is plastic deformation here. Plastic deformation. So plastic deformation simply means that deform permanently. So we can say deform permanently. So we can say deform permanently, and does not return to original size and shape. So that kind of deformation we classify as plastic deformation. Now if you look at this given option, you can see this, we apply force, this deform. So it has this much extension at this point. But when we remove the force, it again come back to this. So it means it was deformed temporary. So this is elastic deformation. So I'll be just writing E for here. So this is elastic. It deformed temporary. Now if you look at this one, so when we apply the force, it extension in this one is this much. But when we remove the force, it come back to this point again. So it means there is no extension when we remove the force. So it means this is also elastic. Now if you look at this one, first of all, when we apply force, if you look at the loading curve, we have this much extension at this point. But when we remove the force, if you look at the unloading curve, At the end, there is no extension. So it means it was deformed temporary. So this is also elastic deformation. I hope now you understand what is elastic deformation. Now, if you look at the last option, when we apply force, if you look at the loading curve, it has this much extension at this point. But when we remove the force, after removing the force, when the force is zero, so you see it still has this much extension. So this is remaining extension when the applied force is equal to zero. So it means this has been deformed permanently. So this is plastic deformation. So this is plastic deformation. I hope this is clear to you. Now you understand what is elastic deformation and what is plastic deformation. I hope next time you can answer this type of questions with confidence. And if this video was helpful, please like and subscribe, and also leave some comments in comments section. And if you need more help and you are looking for extra resources, please join Patreon. On Patreon you will see a lot of resources, and the link for Patreon is in the description of this video. So we will stop this video here, and next video will be coming very soon. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October November 2023, paper 1, variant 1. In today's lesson, our main focus will be on waves. We will discuss all waves questions from this paper. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of this topic, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 20 says two waves pass through a point P. The graph shows the variation with time t of the displacement s of the two waves at point P. What is the phase difference between the two waves at point P? So we have two waves. First of all, we need to check, do they have the same time period or not? If you look at this wave, this has time period of 8 seconds, and if you look at this wave, this also has time period of 8 seconds. So they have the same time period. So we can find out the phase difference. And also we need to understand the ratio between the time difference, delta t divided by time period. This is equal to phase difference divided by 360 degrees. 360 degrees. So we need to find out, for this question we need to find out phase difference. So the phase difference simply will be equal to 360 degrees times time difference divided by time period. So we need to find out time difference. So to find time difference, we have to take 2 points, same points on two waves. So let's say we take this peak of one wave, so we also need to take the peak of another wave. So you can see what is the time difference between these two. I hope you will simply say this time difference is equal to 1 second. So delta t is equal to 1 second. Now simply we can plug in values. So we have 360 degrees time 1 second divided by time period, that is equal to 8 seconds. Now if we solve this one, we will get 45 degrees. So the answer for this question is B. So this is how you can figure out. This formula you can also extend to path difference. So this ratio is also to path difference divided by lambda. So sometimes they will give you the time difference, they will ask you to calculate path difference, sometimes they will ask you to calculate phase difference. So this is the main idea. Question can be different, but concept is the same, because this is just like a tool. This tool is the same. There can be different machines, but you can mean different machine there can be different question, but you can use the same tool. So this is the main tool. Question 21 says, which row is correct for both progressive transverse waves and progressive longitudinal waves? If you look at given options, first option says contains compressions and rarefactions. No, transverse waves, they do not contain compression and rarefaction. This is property of longitudinal waves. Some can travel in vacuum. No, longitudinal waves cannot travel through vacuum. So this is property of longitudinal waves and this is property of transverse waves. So option A is not correct. Now, if you look at option B, transverse waves can be polarized. Yes, this is right. Contains compression and rarefaction. This is also correct. So the answer for this question has to be B. Option C says vibrations are perpendicular to direction of travel of the wave energy. This is true for transverse waves. Can be polarized? No. Longitudinal waves, they just vibrate in one plane, so they cannot be polarized. Some can travel in vacuum. This is correct. Like electromagnetic waves. Electromagnetic waves are transverse waves, so they can travel through vacuum. So this is true. Vibrations are perpendicular. No, this is incorrect. Vibrations are parallel. So this is incorrect. So this is also not possible answer. This is also not possible answer. So the answer for this question is B. A nice question about properties of longitudinal and transverse waves. Question 22 says a toy drone emits a sound of constant frequency 800 Hz. The speed of the sound in the air is 330 meters per second. The drone moves along a straight path directly towards an observer and then continues in a straight line directly away from the observer. The speed of the drone is constant. What is the velocity of the drone when the frequency of the sound heard by the observer is 850 Hz? So this is quite straightforward question if concepts about Doppler effect are very clear. So what is the first thing we need to do? We need to look at given frequencies. Frequency of the source is given to us. So this is 800 Hz. And observed frequency is also given to us, that is equal to 850 Hz. As in this case, observed frequency is greater than frequency of the sound produced by the source. It simply means that source is approaching. So this is the first thing we can infer from the given data. Now, if you look at given options, it means option A is not possible. This is moving away, so this is incorrect. This is also incorrect. So we can eliminate option A and B. So in the exam, quickly, if you look at these frequencies, you can find out source is approaching. So you can quickly eliminate A and B. Now, answer can be C or answer can be D. Now, simply we have to use the formula for approaching source. So we can write on observed frequency. This will be equal to speed of the wave over speed of the wave minus speed of the source and multiply with frequency of the source. For this question, we need to find out speed of the source. So if we cross multiply, we will get here speed of the wave minus we have speed of the source times observed frequency. This will be equal to speed of the wave times frequency of the source. We need to find out, in this case, Vs. So we can further rearrange. We can write down speed of the wave minus speed of the source. This will be equal to speed of the wave times we have Fs divided by F naught. We need to find out Vs. So simply we can write down here now the Vs. So Vs will be equal to V speed of the wave minus speed of the wave times we have Fs divided by F naught. Now simply plug in values, you will get Vs is equal to 19 meters per second. So the answer for this question is C. So this is how you can figure out. speed of wave is given. So this is the speed of wave. Let me highlight, this is speed of the wave. So we have speed of the wave, we have fs, we have f naught. Simply plug in, this is the final answer. Question 23 says, which statement about electromagnetic waves in a vacuum is correct? This question is about electromagnetic spectrum. Every paper, every year has one question about electromagnetic spectrum in paper 1. So it's very important that you remember electromagnetic spectrum. You need to understand the order of electromagnetic waves. You need to remember the wavelength of electromagnetic waves. And all electromagnetic waves, they have the same speed in vacuum, so you can calculate the frequency. Now, if you look at these given options, option A says infrared waves have shorter wavelength than visible light. This is incorrect. They have longer wavelength, so this has to be longer. So it means option A is incorrect. Microwaves have longer wavelength than radio waves. Microwaves, they have higher frequency, but they have shorter wavelength. So it means option B is also incorrect. Ultraviolet waves have higher frequencies than visible light waves. Yes, this is true. So answer for this question has to be C. Gamma rays have lower frequencies than X-rays. Gamma rays, they have higher frequencies. So this is also incorrect. So they have higher frequencies. So for this question, you need to remember electromagnetic spectrum. So this is also incorrect. B is also incorrect. So simply you need to understand Granny's X box. So let me write down here. Granny's X box use volts in my room. In my room. So with this one sentence, you can remember the order of EM waves. So G is representing gamma. These are gamma waves, you can say gamma radiations. X is representing X-rays here, and U is for UV light, V for visible light, and I for infrared. So this is for infrared, M for microwaves, and R for radio. So this is the order. And I hope you are very clear about this one. If we go from gamma to radio, wavelength is increasing. So we will say wavelength, this is increasing. But if we go from radio to gamma, you need to understand frequency is increasing. So frequency increases and energy is equal to HF. So it means that energy also increases if you go in this direction. Question 24 says vertically polarized microwaves are emitted from a source. The microwaves are detected by a receiver that is connected to a CRO. The waveform displayed on the screen of the CRO has an amplitude of 2.6 centimeters. A metal wire grid that acts as a polarizing filter is now placed between the source and the receiver. The filter is oriented so that the plane of polarization of the transmitted wave is at an angle of 20 degrees to the vertical. The distance between the source and the receiver is unchanged. The settings on the CRO are also unchanged. What is now the amplitude of the waveform displayed on the screen of the CRO? So for this question we have A naught, means initial value of amplitude is given to us, and we need to find out new value of amplitude. A new, simply we need to find out. So for this question simply we have to use Malice's law. According to Malice's law, I transmitted, this is equal to I incident times cosine square of theta. This is the angle between light and transmission axis. But we also understand that intensity is equal to K times A square. Now simply we can replace this I, so we can say it will be new amplitude square times K, and this will be K A naught square time cosine square of theta. Theta is the angle between light and transmission axis, or we can say polarizing filter, axis of polarizing filter. Now K we can cancel from here. We need to find out A nu. So this will be equal to A naught square cosine square of theta. We have to take square root of this side. Now from here we can get the final value of A naught. A nu. A naught is 2.6 centimeters, so we can use this is 2.6 square, and cos of angle is 20 degrees, so we have cosine of 20 degrees square, and we need to take the root of this, and our final answer in this case will be 2.4 centimeters. So this is the final answer, and this is how you can figure out. So simply you have to use Malice's law, and the second thing you need to understand is intensity is equal to K times A square. So these two things you need to understand, and then you can figure out the answer for this question. So the answer for this question has to be D. Question 25 says, in an experiment, a stationary wave is formed on a string stretched horizontally between two fixed points. Which statement about this experiment is correct? This question is just about stationary waves. You need to understand some basic characteristics of stationary waves. Let's try to understand some basic characteristics of stationary waves. This point is node, this point is also node, and this point is the anti-node. And particles between all the particles between any two consecutive nodes, they are always in phase. But all the particles, they have different amplitudes. And also, if I imagine one particle here, after time t/4, this particle will be at this point. And if I take another particle on this string, after time t/4, this particle also will be on this horizontal line, and particle here after time t/4, this also will be here, and so on. This particle also will be here. Now if we draw one horizontal line here, so draw this horizontal line here, after time t/4, we will see all the particles on this horizontal line. So this is only for one loop. Now when we have two loops, what is happening in that case? We can draw first of all this horizontal line here. So this is our equilibrium position. Now we can mark some points here. So let's say particle is at this point. After time t/4, this particle will be here, and particle here after time t/4, this will go down, and this particle will be here, and particle here after time t/4 also will be here. And if you look at this particle, because this particle initially will be moving down, then this particle will be moving up. And after time t/4, this particle also will be at this horizontal line. We can use different color now, will be on this horizontal line. And if particle is here after t/4, it also will be on this horizontal line. And particle here after t/4, this also will be on this horizontal line. All these particles between these two nodes, always they will be in same phase, and particle between these two consecutive nodes, they also will be always in same phase. And all these particles, they will have different amplitudes. And particle in this loop, if I say loop A, means this loop between these two nodes. Then if I say this loop is B, these particles, they will be in antiphase all the time. So these are some basic points we need to understand. If this is clear to you, now if you look at given options, you can easily figure out the answer. If you look at option A, at certain times, the string between two nodes is horizontal with all points having zero displacement. Yes, this is true. We have discussed between two consecutive nodes. at one time all the particles, they are just lying on this straight horizontal line. So it means option A is true. This option is correct. Each point on the string between two antinodes has an oscillation with the same amplitude. No, each point on the string between two antinodes, mean between this antinode and between this antinode, is telling us on a string each point, no, they have different this has maximum amplitude, this is minimum and even lower. So here amplitude is equal to 0. So it means this option is incorrect. The number of nodes is equal to the number of antinodes. So if you look at first loop, we have two nodes, but we have one antinode, so it means they are not equal. And if you look at this one, we have 1, 2 and 3 nodes, and we have two antinodes. So number of nodes is greater than number of antinodes. So it means this statement is also incorrect, not equal. So it has to be not equal. Two adjacent antinodes oscillate in phase. No, means particle at this point, it will be moving down, particle move, they are in antiphase. So this has to be antiphase. So these are the points you need to understand. If you have clear understanding of these points we have discussed for this question, it means you have quite good understanding of stationary waves. Question 26 says, a musical organ produces notes by blowing air into a set of pipes that are open at one end and closed at the other. The speed of sound in the air in the pipes is 320 meters per second. What is the lowest frequency of sound produced by a pipe of length 10 meters? Lowest frequency. So it is given to us one end open and one end closed pipe. So simply we can imagine this is one end open, one end closed pipe, and the length of this one is given to us, that is equal to 10 meters. So simply we can say this is 10 meters. Lowest frequency means the longest wavelength. So simply we can draw first of all the stationary wave inside this one. So this is how the stationary wave will look like. And if you look at this point is the node and this point is the antinode. So in this case L is equal to lambda by 4. So simply we can say in this case lambda by 4, this is equal to L, and L is equal to 10 meters. So lambda is equal to 40 meters. We need to calculate frequency. So frequency is equal to V divided by lambda. Value of V is given, that is equal to 320 meters per second. Value of lambda is equal to 40. So we can simplify, we can cancel this 0 with this 0, so we got 8. So this one is the lowest frequency. So the answer for this question has to be B. So it's very important. Question is asking you the lowest frequency. Question 27 says, in an experiment, water waves in a ripple tank are incident on a gap as shown in the figure. Some diffraction of the water waves is observed. Which change to the experiment would provide a better demonstration of diffraction? Mean how we can increase the amount of diffraction. For this one we need to understand there is a significant diffraction. You can simply say significant diffraction takes place. Significant diffraction takes place when lambda is about equal to the gap size. About equal to gap size, and if we keep on increasing lambda, diffraction will go on increasing. So this is the point we need to understand. If you look at this one, gap size, in this case gap size, this is much greater than lambda, so we have to bring them closer. So we have to increase the lambda. So if we increase lambda, it means gap size will be getting closer to the lambda, so diffraction will be maximum. So this is the main point. We have to increase lambda or we need to decrease this gap size. So they are almost equal to each other. Now if you look at given options, increase the amplitude of the waves, it has no effect on diffraction, so it has no effect. It will not increase diffraction. Increase the frequency of the waves. If we increase the frequency of the waves, it means lambda will go down. If lambda go down, lambda even gets smaller, so it means diffraction will go down. Increase the wavelength of the waves. Yes, so this is possible answer. Increase the width of the gap. This will also minimize diffraction. So this will increase diffraction. So the answer for this question is C. So this is the main point you need to understand. When significant diffraction will take place, then lambda is about equal to gap size. Question 28 says light of wavelength lambda is emitted from 2-point sources R and S and falls onto a distant screen. At point P on the screen, the light intensity is 0. What could explain the 0 intensity at P? 0 intensity means that there is dark fringe. So we can say dark fringe. So one simple way to say is dark fringe. It also means that destructive interference. So we can say destructive interference. Destructive. And destructive interference between two waves takes place when they are anti-phase. When they are anti-phase, or we can say phase difference is equal to 180 degrees. So these are main points. Now if you look at given options, for option A it is given to us light from two sources is emitted 180 degree out of phase and path difference to P is 1/2. So this is 180 degrees phase difference and this is also 180 degrees. So when they will reach at point P, it means these two waves, they will be in phase. It simply means that at this point they are in anti-phase. So we can say they are in anti-phase. But when they reach at this point, because the path difference is equal to lambda/2, it means 180 degrees phase difference. So when they will reach at this point, these two waves, they will be in phase. So there will be constructive interference. So it means intensity will not be equal to 0. So option A is not correct. If you look at option B, it is given to us light from the two sources is emitted in phase. In phase. This is very important. And path difference is equal to lambda. So initially they are emitted in phase. So we can clear this one. So they are in phase here. And path difference is equal to lambda. It means phase difference is equal to 360 degrees. So when they will reach at this point, again they will be in phase. So this is also constructive interference. It means option B is also not possible answer. So this is incorrect. For part C, it is given to us light from the two sources is emitted 90 degrees out of phase and path difference to P is lambda. So here they have phase difference 90 degrees. If path difference is equal to lambda means equal to 360 degrees phase difference. So here again phase difference will be 90 degrees. So interference will not be 100% destructive interference. So in this case intensity also will not be equal to 0. So this is also not possible answer. Light from the two sources is emitted in phase and path difference is equal to lambda/2, means the phase difference is 180 degrees. So here they are in phase, and at this point when these waves they will reach, they are 180 degree out of phase. So let me draw this bigger one. So they will be 180 degree. At this point they will be 180 degree out of phase. So we can draw they will be 180 degree out of phase. So in this case intensity will be equal to 0. Resultant intensity will be equal to 0. So the answer for this question is D. So this is how you need to figure out. Nice question, conceptual. Question 29 says a beam of red light of wavelength 720 nanometers is incident normally on a diffraction grating. and produces a diffraction pattern on a screen placed parallel to the grating. The beam of red light is replaced with a beam of electromagnetic radiation of wavelength X, which is incident normally on the same diffraction grating. Same diffraction grating means that D is the same, means the slit separation is the same. The third order maximum for the electromagnetic radiation of wavelength X is at the same position, very important one, at the same position on the screen as the second order maximum for the red light. Same position, it means that angle is the same, so we can say theta is the same, position is the same. So theta same because it is given to us, position same, so it means angle is the same. So if you have understood these 2 points, we have done this question. Now let me explain a little bit more. For diffraction grating, we need to understand d sine of theta. This is equal to n times lambda. For this question, it is given to us that d is the same for both of them and theta is the same, so it means sine of theta is also the same. So what does it mean? It means that product of n means the fringe order and lambda, this is constant for red light and also for X. So it means that n times r, lambda of r means the red light, this is equal to n of X times lambda of X. For this question, we need to find out lambda X. So we can say lambda X, this will be equal to n for red light times lambda of the red light divided by n for X. So n for r is given to us, so we have third order. This is for X, so this is third, and for the red is the second order. So we have 2 here, and the wavelength of red light is given, that is 720 nanometers. We no need to change units, and nx, this is theory, so divided by this. Now if we simplify this one, we will get our final answer, that will be equal to 480 nanometers. So this is how you need to answer. I hope this question makes sense to you. And if this video was helpful, please like and subscribe, and also leave some comments in the comments section. And if you're looking for more help and extra resources, please join Patreon. See you next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from October-November 2023, Paper 1, Variant 1. In today's lesson, we will focus on electricity and radioactivity questions from this paper. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 30 says the current I in a conductor is given by the equation shown. What does the letter small n represent in this equation? So we need to understand n is the number of charge carriers per unit volume. So simply we can say n is the number of charge carriers per unit volume, or you can say number of free electrons per unit volume. We can also say this is number density because we are dividing numbers by volume, so we can say this is number density. We can also call this is number density, and we call rho is the mass density because in rho we divide mass by volume, so this is the mass density and this is number density. So if you divide something by volume, we call it density. So mass density, mass divided by volume. Number of charge carriers divided by unit volume is number density. So very important to understand things like this. Now if you look at given options, for option A it is given to us the charge carried per charge carrier. No, this is not right answer. Number of charge carriers per unit area. No, it has to be per unit volume, so this is incorrect. So this is incorrect. So B is also incorrect. The number of charge carriers per unit volume. This is correct. So the answer is C. Total mass of charge carriers per unit volume. This is mass density. This is incorrect. So the answer for this question is C. Question 31 says, in the circuit shown, the battery has an electromotive force of 6.0 volts and negligible internal resistance. The three resistors each have resistance capital R. The total power dissipated in the resistor network is 24 watts. What is the value of capital R? So in this case, power is given to us. So we can say power will be equal to V squared divided by R total. So this is the total resistance of this network. So here we are talking about the total resistance. And total resistance of this network, simply we can find out these two resistors, their total resistance is 2R and this is R. So and they are connected in parallel. So we can say this will be equal to 2R multiplied by R divided by 2R plus R, because they are connected in parallel. And so we will get 2R square divided by 3R. So we can cancel R with R. We will get 2 by 3R. So this is the total resistance. So we can plug in values here. Value of V is given. PD across the terminals of the power supply is given, that is 6. So this is 6 square divided by 2 by 3 times R. So we can say this is 2 by 3 times R. If we simplify this one, we can say this will be 36 times 3 divided by 2R. And value of power we have, that is equal to 24 watts. So we can say this will be equal to 48R, that is equal to 36 times 3. We can simplify, we can say R will be equal to 36 times 3 divided by 48. So we can cancel this 3 with this, so we will get 16, and we can divide this one by 4, so we will get 4, and if we divide this one by 4, we will get 9. So we got 9 by 4. So if we divide this one by 2, we will get 4.5, and if we divide this by 2, we'll get 2. So we got 4.5 divided by 2, so we will get 2.25. So we can say R will be equal to 2.25 up to 2SF. We can say this will be equal to 2.3 ohms. So the answer for this question is D. So this is how you can answer. This is the main concept. So you need to find out the total resistance, and this is how you can calculate total resistance of this network. So this one is the total resistance. Then simply use the formula and you will be able to get answer D. Question 32 says, which graph could show how the resistance capital R of a filament lamp varies with the applied potential difference V, as V is increased to the normal operating PD. For filament lamp, we need to understand how PD affects the resistance. So we can say filament lamp. For filament lamp, if PD increases, mean the potential difference across filament lamp increase, resistance of filament lamp will also increase, because when PD increases, it means more electrical energy will be converted into thermal energy. More electrical energy will be converted into thermal energy. So it means that temperature of filament lamp will increase. Thermal energy, so it means temperature of the filament lamp will increase. As temperature of filament lamp increases, resistance of filament lamp increases with PD. Now if you look at given options, this is telling us resistance is decreasing, so we can simply eliminate this one. This is telling us resistance remains constant with PD, so we can also eliminate this. Now the answer can be A, or answer can be B. This is starting from 0. This is telling us when there is no potential difference across filament lamp, its resistance is equal to 0, and that is not possible. It must have some resistance even when there is no PD across filament lamp. So we can also eliminate this. So the answer for this question is C. This is how you need to answer. Question says a piece of conducting putty is in the shape of a cylinder of length 60 millimeters and diameter 20 millimeters. The resistance between the ends of the cylinder is 20 ohms. What is the resistivity of the putty? Pretty straightforward question. So it is given to us the shape of the putty is cylinder. So we can simply draw this cylinder first of all. So this is the cylinder. The length of the cylinder is given to us. So we have value of L, that is equal to 60 millimeters, and diameter is given to us, that is equal to 20 millimeters. And it is also given to us the resistance between the ends of this cylinder, between these two ends, resistance is equal to 20 ohms. We need to find what is resistivity of the putty. So simply we can use R is equal to rho L by A. We need to calculate for this question rho. So rho is equal to RA divided by L. So value of resistance we have, that is equal to 20 ohms, and value of cross sectional area, simply we can calculate pi by 4 d square, and value of diameter is given, that is 20 millimeters, and square of this. We need to divide this one by the length of this conducting putty, that is 60 millimeters. Now if we solve this one, we will get 0.10 ohms meter. So this is value of resistivity. Quite straightforward question. For this question, simply you need to understand, you have to use this equation. So the answer for this question has to be B. Question 34 says, which statement about the electromotive force of a cell is always correct? So first of all, let's try to understand a little bit about electromotive force. Electromotive force is the electrical energy provided by the battery per unit charge. So we can say electrical energy provided by the battery per unit charge. We can also say this is the amount of other forms of energy. We can say amount of other form, or we can say this is the amount of chemical energy. So we can simply say this is the amount of chemical energy converted into electrical energy per unit charge. So we can say amount of chemical into electrical per unit charge. So this is per unit charge. So this is how we can define electromotive force. In a simple language, you can simply say this is the amount of electrical energy provided by a cell to unit charge. That is the electromotive force of that cell. How much electrical energy a cell is giving to the unit charge passing through it, that is the EMF of that cell. If you look at given options, the EMF is the energy converted from electrical to other forms. No. EMF is the amount of chemical energy into electrical. So this is actually for the potential difference. This is how we define potential difference to other forms per unit charge. So this option is incorrect. The EMF is the energy provided by the cell per unit charge passing through it. Yes, this is true. So this is correct answer. The EMF is the potential difference across the internal resistance of the cell. No, this is lost voltage. So we can say lost volt. So this is also incorrect. The EMF is the potential difference across the terminals of the cell. That is terminal PD. So that is not the EMF. So that is terminal PD. Because EMF of a cell, this is equal to terminal PD plus voltage lost, V lost. And so EMF is equal to this. So the answer for this question has to be B. I hope this question makes sense to you. Question 35 says, Kirchhoff's first and second laws are a consequence of the conservation of which quantities? So the first law, Kirchhoff's first law, is based on conservation of charge. So this is based on conservation of charge, because the current entering and leaving a junction should be the same. I entering a junction, has to be equal to I leaving a junction. So charge has to be conserved. And the second law is based on conservation of energy. So this is based on conservation of energy in any loop. Sum of EMFs has to be equal to sum of PDs, means energy has to be conserved. So first is based on charge, second is based on conservation of energy. So it has to be charge and energy. So the answer is A. Question 36 says a circuit contains a cell of electromotive force capital E and internal resistance small r connected to a resistor of resistance capital R. The current in the circuit is I. Which equation is correct? This question simply we can answer using Kirchhoff's second law. According to Kirchhoff's second law, in any loop, delta V has to be equal to 0, or simply we can say sum of EMFs in any loop has to be equal to sum of PDs. So in this case we have EMF that is only one, so we have E. This one has to be equal to I times capital R plus I times R. So this is the simplest way to answer this question. We can also little bit rearrange this one. If you look at the options, we have E on one side, so this is not possible answer because we have plus sign here, and this also, if we bring this side, this will be negative, so this is also not possible, this is also not possible. So the answer for this one is A. So we can rearrange, so we can write down this is E minus I times R, this is equal to I times capital R. So the answer for this question is A. This is a typical question, so you need to understand EMF is equal to terminal PD plus V lost VR. So we can say E, this has to be equal to I times capital R plus I times small r. So we can also take I common from here, so this will be R plus small r. So E. So these different forms of this equation you need to understand. So the answer for this question is A. So this is just based on conservation of energy. Question 37 says a potential divider consists of two resistors of resistance R1 and R2 connected in series across a source of potential difference V in. The PD across R1 is V out. Which changes to R1 and R2 will increase the value of V out? This question is just about potential divider. So first of all, we can simply imagine, let's say total current in the circuit is I, and current passing through R1, let's say this is I1. So we can say I1 has to be equal to I total because these two resistors, they are connected in series. So we can say I1, this will be equal to V out divided by R1. V out divided by R1, and I total has to be equal to the total PD across these two resistors divided by the total resistance. So from here we can find out V out. So V out from here will be equal to R1 divided by R1 plus R2 multiplied by V in. V in is constant because this is the total PD across these two resistors, so this quantity is constant. Now simply we need to look at this one. Is this overall increasing or decreasing? If it increase overall, it means V out will increase. If it overall decrease, it means V out will decrease. If it overall stays same, it means V out will stay same. Now first of all, look at option A. For option A, we can write down V out. So V out, we have, this is R1 is double, so we can say this is 2R1. R2 is also double, so this is 2R1 plus 2R2 times we have V in. V in is constant. Now you can see from here, actually, if I take 2 out, so this is here, we can say this is 2 times R1 plus R2, and this is multiplied by V in. So you can simply see from here that this 2 will be cancelled with this 2. So there is overall no any increase. So it means that this is not possible option. Now if you look at option B, the second one, so we can write down B here. We have V out, that will be equal to 2 times of R1 divided by 2 times of R1 times R2 is half, so this is 1 by 2 R2. So this is the overall, and here we have V in. Now if you look at this now, this numerator increases by 2, increases 2 times, but this is not increasing by 2. This is not increasing by 2. So it means that overall this increases, because numerator increases by 2, but this does not increase by 2, so it means overall this increases. If overall this increases, so it means this also increases. So the answer for this question is B, because this is a constant. Now if you look at option C, so let me write down first C, half and double. So we have V out, we can say this will be equal to R1 is half, so this is R1 divided by 2. Numerator become half. How about denominator? So this is R1 by 2, plus we have 2 times of R2, so it does not decrease by 2. This decreases more, so it simply means that overall this decreases, this factor, so it means that this decreases. And if you look at option D, so this is very similar to option A, so we can say this is V out, this is R1 by 2, and here we have R1 by 2 plus we have R2 by 2, and this is multiplied by V in. Now from here you can see we can take factor out, so we have 1 by 2, we can take common, so here we can also take 1 by 2 common, so we left with R1 plus R2, so multiply by V out. So now you can see simply this factor will be cancelled, so overall there is no change, so it means V out will be the same, so V out will stay same. So in this case stays same, in this case increases, in this case decreases, in this case also stays same. So the answer for this question is B. I hope this makes sense to you. If this is clear to you, please like and subscribe, because your encouragement is very important. And if you need more help, and if you're looking for extra resources, please join Patreon. Question 38 says 2 alpha particles with the same kinetic energy are moving towards and then deflected by a gold nucleus. Which diagram could show the paths of the 2 alpha particles? So we can say, first of all, let's say this is alpha particle A and this is alpha particle B, and here we have nucleus. Alpha particle has positive charge and gold nucleus also has positive charge. It means that there will be repulsive force between alpha particles and gold nucleus. Then repulsive force will be equal to K Q1 Q2 over D square. If D is small, it means force will be greater, force will be stronger. As in this case, A is closer, so it means force on A will be greater than force on B. So if the force is greater, it means A will also deflect more. So we can say more deflection for A. So these are the points we need to understand. Now if you look at option A is deflecting less, B is deflecting more. Actually this is showing B is attracted, so this is incorrect. And if you look at option B, this is telling us B deflect more, so this is incorrect, so B is also incorrect. If you look at C, this is telling us attractive, so this means attractive, but force is repulsive, so this is also incorrect. And if you look at D, so A deflect more, B deflect less, and this is showing the force between the alpha particle and gold nucleus is repulsive. So the answer for this question is D. So the answer is D. Question 39 says, which nuclide is formed when carbon 10 undergoes beta plus decay? So it is given to us, it is a beta plus decay. So simply we can write on, we have carbon 10 here, it undergoes beta plus decay. So simply we can say this is an other element that is formed. So we can say this is unknown element. Plus it is given to us, this is beta plus decay. This is positron, so this is antiparticle, so it has to be electron neutrino. So here we have 6, so here atomic number has to be 5 and mass number does not change, so this has to be 10. Now if you look at given options, we have 5, so it means this is boron, so this is boron. So the answer for this question has to be C. So C is the right answer. Question 40 says, a particular hadron is composed of 3 quarks and has 0 charge. What is a possible quark composition of the hadron? So it is given to us, hadron has 3 quarks and the charge on hadron is equal to 0. So we can simply look at these given options and we can figure out the answer. So first of all, we need to understand the charge on down quark is minus 1 over 3e. And the charge on the strange quark also is equal to minus 1 over 3e. And charge on up quark is plus 2 by 3e. For option A, we can say this is minus 1 over 3e, minus 1 over 3e, minus 1 over 3e. So it means we will get in this case minus e. So the charge is not 0. It means this option is not possible. And if you look at option B, we have up quark 2 by 3e, minus we have 1 by 3e, and we have minus 1 by 3e. And this is equal to 0. So it means this composition is possible. We can also check the other given options. So this is up quark, so we have 2 by 3e, we have 2 by 3e, and we have minus 1 over 3e. And this is not equal to 0. So this is not equal to 0. So it means C is not possible. We can also check D. For D, we have 2 by 3e, we have plus 2 by 3e, and we have minus 1 over 3e. And this is also not equal to 0. So the answer for this question is B, and this is how you can figure out. That's all for this paper. I hope this video was helpful. If this video was helpful, please like and subscribe, and also leave some comments in the comments section. If you need more help and if you're looking for extra resources, please join Patreon, and the link for Patreon you can find in the description of this video. See you in next video.